Hello. It is time. All right. So hopefully today, by the end of today, the crawler is moving, and I am going to rename it to crawler at this point. I mean, spider's kind of like an exaggeration. It's a crawler. Gonna do cool. All right. Alrighty. So the first thing that I have is I need to reorganize character controller to support custom spring function implementation. Should be such that crawler can just override that method and everything else works as expected. Okay. Let me think about that. I need to be sure that however I extend from character controller. The first issue is definitely the spring. That's kind of like hard built into character controller, is that it expects to have a spring. Which is not necessarily the case. I mean, I guess I could think of spider as, crawler or whatever, as being a pretty unique case where maybe I don't want that exactly. Maybe. Shapecast assign. Yeah, I guess the first thing I do is I probably... This is related to floor collision, right? This is related to, like, detecting a floor. The presence of a floor. Right, and I think what I believe I thought was calculate ground force. All this stuff will just go into calculate ground force. So whoa. And then everything else from there works off of that. So let me find where shapecast is really used. So it's used here prior to this call. Which honestly is just part of calculate ground force. There can be like an early return for this, for these two things. And then after that, yeah, it's only used in calculate ground force. And I modify spring force as a result. I'm also expected to set up all ground related things. Because here I do spring force plus inverse mass. And if friction is ground friction. Here's definitely a problem. There's just a lot of, it's not so easy to plug into this one. There's maybe a little bit of spaghetti going on in the fact that this is being written to after or more than once using ground friction. Oh, well, hang on. Ground friction is calculated. Ground friction is calculated. Though it is really simple, it's just a friction coefficient times the relative velocity. That's all that it is. It's just a direction and a scale factor. So it's not so bad. Okay. So first thing I gotta do, I gotta override that method. So I think that method is ground force. There's movement, incline related things, which is totally fine. That makes sense. But then I have this stopping power. This stop force. And it really does suck. It really does suck. Remove spring plus gravity. Which, I mean, I guess does nothing if there's no spring. But if it's there... Oh, man. I'm not sure entirely what's wrong with this one. I think the wrong part is probably, or used to be this. I think it's still wrong. I still struggle in my head to visualize how to construct the vector of what it really means to be moving along the ground, or at least in terms of like, your ability to stop on the ground, relative to things, I guess. Alright, but I think I can just move this up. So I think the first thing I'll do is I'll put I'm just going to start rewriting it from here. So to calculate ground force state, and then I can do this check for debug. If we are on the floor, these debugs can just move up here. Right? So I call that. And now inside of ground force, I'm going to have these. So I guess I can just say if not shapecast well, I guess not really a return, but I guess I would actually say if shapecast and is colliding, then I can say this. And I can say otherwise. So there's just all kind of like the switches to flip things around, and then that can just be a return. Okay, so if we have a shapecast, and then shapecast is colliding, I just do this simple test. If we were not on the floor, mark ourselves being on the floor. Otherwise, we don't have a shapecast or it's not colliding. If we were marked on the floor, mark ourselves not on the floor and turn all this stuff off. And then we return no matter what, if we have no collisions. So this should change nothing. This should change nothing. All movement should be... Okay, well, I was going to say this should change nothing. This now just gets deleted. Okay. 61 errors. Bone index -1 is out of bounds. Okay. What? Bone index -1 is out of bounds. From who? What? What are you talking about? What? Is it... I don't understand why that's happening. All right. Get bone rest. Are you serious? What does it come from? Where does it come from? Dude. Godot? You're drunk. Okay, so it's actually just a bug. There's just a bug. Because it happens when it's loading and then it stops happening. I don't think it's that I have one of these with a bad name either. That wouldn't make sense because I literally redid all these. And it's also turned off. So find bone. That would make sense. Near a find bone test. Let's see. Find bone. How many times does this happen? It happens 60 times. This runs 60 times. I do happen to have 6 chains, which means it could be happening 10 times for each of those chains. Though that doesn't make sense. Ooh, I do have 2 iterations though. What if I change that to 1? Do I get 30? Okay, no, it's still... whatever. Turn this off. Disabled. Why? Stupid. I have 19 of these, but they all work. I don't know what's up with that. All right. So it happens when it loads. I mean, my guess is it's probably validate axis. It doesn't seem like this. But then it's -1. There's no find bone here. Is it an iterate? If they have tools enabled. It's not even code that runs. Why doesn't it print the stack trace? This wasn't happening yesterday, was it? Yeah, I don't think this was happening yesterday. I mean, maybe it wasn't happening yesterday because this was like broken and it wasn't even getting that far because like the character controller script would break. But even if I disable this, it still happens. It's definitely some kind of thing where this runs twice. But I just don't. It doesn't make sense to me. It doesn't make sense. What the hell? Oh, that's me. Okay. I saw a pull request. I'm like, why is there a pull request on mine? Also, how does this one slip through, by the way? How does this slip through? I just wish it printed a stupid stack trace, man. I just wish that these error messages would give you a stack trace. Because when they're from internal code, there's no... You don't know how it got there. You just don't know. Okay, so I'm going to have to do a compile and see where this error comes from and fix it, because I just won't continue with that happening. Oh, that's funny. It's just straight up just does not exist here anymore. Oh, it's just print stack. Or not. So stupid. Like, the thing that sucks is when you do this from your code, it gives you that. It tells you this line fails, and then it tells you, oh, we called it from this GDScript function. I'm pretty sure, at least. I don't know why it doesn't do that for its own code. Whoa. I feel like there's just gotta be one up here that's like print the whole stack, right? How did I figure this out before? I feel like every time I figure this out, I actually just have to look at every single call, and I manage to find where it happens. But this one is just, it's called so many places. And I can't be sure. There's just so many calls. I can't be sure where exactly it starts from. I feel most suspicious of something around here, like get bone axis, but I have it disabled, so I don't even know how this is running. Maybe it's init joints? But it's also not running twice. I don't see like a 2 run because it would go through every bone, every one of the chains is 5 bones. Sorry, I have 6 chains, each one has 5 bones. That's 30 errors happening. This is the same error printing 60 times, which means whatever it does, it runs twice. So I would think to see two-bone IK. I don't use two-bone IK. This is a chain IK. But then I would think it would fail twice. It'd be like get bone parent. So that would be, it can't be this one. I don't think I'm using retarget. Iterate IK, get bone 3D, get bone vector, index joint. This doesn't seem to do a test. But this also runs one time, so it's weird. Unless I'm doing get bone vector twice somewhere. Maybe this one? No, because I think normalize prints an error if it's a 0 vector. Right? It should be returning a 0 vector. It's not copy transform modifier because I have like 19 of those. It's not an equal number. It's not happening from skeleton 3D, I think. Maybe it is. I don't know, maybe it is. One second. The thing is, literally, who knows? Well, it wouldn't be here because it would be printing a different error, actually, so it doesn't happen there. It would already be printing that error. I don't know, man. I don't know. Who knows? I just wish these guys were like, oh, here's how you do stack trace. They did not just seriously say you can't get a stack trace. Oh my god. No, that's just not possible. The computer has no idea what it's doing right now. The computer's just running some code. It doesn't know where it is in the call stack. What do you mean the computer should know where it is in the call stack? It doesn't know. It knows, man. It knows. It knows. The computer knows exactly where it is. And it knows exactly how it got there. Oh my god. Alright, how about just print stack trace? Oh yeah, the call stack. Stack trace. The hell is stack trace? Include stack trace. That. Okay. Let's go to skeleton. And I guess I just do a simple what was it? Stack. And then I would just include this at the top of this file. I could put it in the middle of the file, but, you know, just to be nice, I'll put it at the top. Whoa, that's a crazy copy paste there. Alright, we're compiling. Because... that was stupid. And they have a bug. How do they track their own bugs down? I still don't understand why they don't do a stack trace for internal errors. Feels so stupid to me. No member name stack trace. Really? Really? Someone lied to? I did this before. I did this before. I've done this before. How are you supposed to do this? I've written my own thing. I've literally written my own thing. How do you do this? What the hell is that? Using just what is it? Was the this really isn't here? I've done this before. I've literally had exactly this problem where I'm like, okay, there's some internal bug. I think I did this for the audio stream where it would bug out because sometimes it would load like, or not bug out, it would just be laggy or something. No, it would bug out. Sometimes it would return a so it would like return a buffer. I don't know, it's not the exact word, but it serves the explanation. It'll return a buffer that is ready to be used, but it wasn't properly marked as ready to be used. So what would happen is internally it would say, this buffer is already playing audio. We can't play audio with this buffer. But the buffer's not playing audio. Like the buffer could only be in that list to replay if it was done. Is the kind of thing, is like this, the way the code was written. So there's like, it was just like a -1 value was not being set when it should be set. It was literally like, you play it one time, you get it to reuse, you try to reuse it, it says, no, we can't do that, and then it like fixes it, so then it can be reused, so next time it comes back again, it says, oh yeah, we can use that now. All it did was like set a -1. Alright, but this is how I'm pretty sure that's how I did it. I'm pretty sure I used maybe call stack is going to give me the right answer. I'm gonna explode. I definitely did not write an entire thing like this. Godot. All. I'm back. Dog wishes barking. Oh, I know how I did it. I know how I did it. I did print debug, and I think I just give it any message. And then I think that's all I have to do. I don't know why I forgot that, but I think I just do print debug. Because print debug includes stack tracing. I think that's how I did it. And you might think, well, that's in GD script. And you're right. but I'm pretty sure it also works. Not there. Okay, so print debug. It's definitely a real method. Is it debug print? Yeah, because I have to get this method. I don't know, this is weird. I thought print debug works. I'm pretty sure it does work. I just don't know how to use it. There's like... There are some... I've seen prints before. No, I've definitely used it. I've definitely just used a print before. Oh. Okay. Maybe I could try this. Alright, maybe I just say, forget that trash, and I continue on with my day. I just ignore it. I'm just gonna ignore that error. I'm just gonna... That error is not my fault. It's not my fault. I literally disable the thing, and it still prints the error. So, it's not my fault. It is absolutely not my fault. I'm just gonna ignore that. I'm gonna assume it's been found, it's been noticed, they're gonna fix it, and I work on my game. Okay? Work on my game. Work on the game. Yeah, I'm gonna go ahead and make all these named crawler. Because, like I said, spider's an exaggeration for sure of what this is. Okay. I renamed the file. I did not rename the file. What? Okay, now I rename the file. One hundred 78. The file name's changed. Actually, nothing. None of that changed. Oh no, I need to change. Oh my gosh, it did change. Okay. Yep. Yep. Sending this. Okay. I guess I should all... I mean, I saw these errors because I did this and I was walking around. Why is it gone? Why is it gone? Does it just fall through the ground? Oh, it does. It just falls to the ground. Okay. Whatever. Just make sure all this still works. Looks like it's good working. That's a wall. Can't walk up that. The way that the jump works, it actually does turn into a wall jump, sort of. It really does sort of turn into a wall jump. I can't do it from that angle. It does have to be a slanted wall, though. Okay, well, movement looks totally fine. I have some extra errors here. What's the extra errors? Oh, just that printing. Because I'm moving it. And it doesn't like that. But oh well, I can't stop those from happening. Because they're not my fault. Ugh. Okay. Alright. Handle cases where character controller has no typecast and all right. Oh, geez, the yawning is wild. Okay. Oh man, that's gotta go on the to-do. That's just gotta go on the to-do list now. That happens so many times. That's gotta go on that. There we go. Okay. All right, now it's all moved into this, which means if I do okay, so if I give it I guess for now I'll just put a collider on its torso. which I guess I could connect to this, but I don't think I should do that. I'm just gonna put it out here. Well, actually, can I just put it on this? Does it? I don't think it accepts that. Unless I can tell it, like, hey, this is your parent. No, I cannot. Yeah, so it does have to go up here at the top. And yeah, I'm just gonna use this. I don't know why collision shape is offset now. Just, yep. Move it up there. 1.5. Guess this is actually 2.5. Yeah. But that is a problem. So I'll leave it as a capsule. I'll just make it a bit taller, so it fully encloses that. Pretty much fully encloses that. I could make it actually fully enclose that. Okay. So now it's a big thing. It still just falls to the ground because it doesn't have the right collision set up. So you should be on... So I guess I probably need a name for this. Layer 1 is Character World Collider? Not entirely sure about that. No, this is like character... I'll say character... Oh, okay, so I didn't think of this. This has just been something that I've been saying, that I might use a larger collider that doesn't intersect with the ground, but that's not how collision works. Collision is based on bodies, not shapes. I can't have a shape be a certain thing. So, did it save that name? It did. Yeah, see, collision layers are set up per that, not per shape. It'd be kind of cool if they were set up per shape. That'd be nice. I can make it have a different... shapes used for different collision interactions. So I can have... I don't know. Probably what I mean to do is just have like another rigid body that's actually used for like an internal rigid body, I guess, that just tracks with it and has the same mass. Or maybe not has, I don't know. I can figure that out later. But for now, this will be on those layers and interact with those layers. Oh my gosh. Yep. So it's just that's crazy looking. Okay. Um so I've got that collider set up. So what I'd like to do is I guess go ahead and get I'm going to rename this. And I guess I just need an extended script for this. This can just be very generic, I think. So what we're going to do here is I'm going to override the calculate ground force. And well, I'll just make it be equal to gravity. So spring force will just be equal to state total gravity, the opposite of this. So it has no, it won't have gravity, so it will just float there, but it can still be pushed around. Times mass. That should be all I have to do, and now it won't fall. Okay, that's not what I expected to see. It's not what I expected to see. So why did that happen? Why did that happen? Does it just not have the script here? Did I have to open this and now it works? Interesting. Why does it do that? Because this should just be calling that method, and then my method says I've overwritten it. And my method just says to be the opposite of gravity. So it'd be total gravity minus total gravity. So why does it fall? Oh, it's because I don't have custom integration. There we go. Turn that on. Now it works. Okay. And if I push it, it should just start sliding. Yeah, like that. Perfect. Exactly what I want to see happen. All right. So for now, it just totally opposes gravity. That's okay. I guess I can make it a reasonable weight. Also, this is something I haven't really done yet. Because I had the player at 100 kilograms, but I think that's kind of heavy, maybe? I don't know. For me, that's 220 pound. I'm going to do some Halo research here. Halo Spartan weight. I say weight, but it says out of... Wait, what? No. Why am I reading AI right now? They're just straight up wrong. What? This is definitely just like lore, right? There's literally just lore. Oh, this is how heavy. I say heavy. I more just mean mass. is this site so bad? They're putting this guy at 130 kilogram, which is pretty dang heavy. I guess 100's probably fine. If you think about a big guy with armor, maybe that's fine. Maybe it's not heavy enough. I don't know. How heavy would a big crawling robot be? I feel like it probably shouldn't be over 150 pounds. I'm just like, that's just my reference point. So I'll say 64 kilogram in my case. I feel like it shouldn't be much heavier than that. This should make it harder to push this thing. All right. Is he gonna hit that? Oh. Right, I forgot it's weightless. Okay. I thought I was just gonna bounce off the ground, but no, it's weightless. It will just slip under it. Okay. So there's the start. I've now got this running where spring force is just totally opposing gravity. So I guess the next thing is probably just traveling forward. So let's just say desired direction is vector 3 forward, and desired speed will just be 1. So it should go forward very slowly. That's what I want to see. Okay. All right. Now if I turn it, I think it maintains that direction. Okay, well... Oh. All right. He's blasting off. Okay. So... desired direction is relative to its orientation, correct? No, we'll transform it if we have a force ground movement, which transforming just means flattening it. But yeah, it's exactly the direction that I give it. So if I give it world Z, it is always going to try to move along world Z. Okay. So let's have it let's have it walk towards me, I guess. Well, okay. I think what I do is probably get the raycast stuff set up properly. What I'd like to do is I'd really like to have it so that when you're walking forward, I have this like this node that I rotate forward, and that node is attached to all the raycasts of that leg pair. Sort of, right? I'd have leg targets, and then I would have a node for, I guess I'll just say middle. Whoop, I just mean node 3D, and then I will name it middle, and these will jump into here. And then I would have a node that is like this. So the idea of middle is that it just sits in the middle. Again, I forgot that those were turned on. And then middle left will be, whoop, that's left. Pretty much there, I guess. Middle right, pretty much there. So then the idea behind these is that, first of all, I also probably just need to turn this off so I can realign. Realign this. Okay. And then this middle left cast should I think they just kind of start here, right? Maybe more like here around this joint. Right? And then I think the idea is I bring this up to here, and then I just make this, bring this out until it's about where it should be. Right, and that looks kind of like its transform. Not quite though. It should, because if this intersects, it's going to intersect somewhere over here on the ground. If we trace that line back. So, yeah, it's not quite ideal. It could be a raycast pretty much down, but I'm not sure. I think it's probably gonna work best if it has this really sharp angle to it. Maybe not. Because if I'm walking up something, yeah, if I'm walking up something, all right, so we're gonna say don't have any angle like that. I can't just go straight down. But let me see roughly. Well, like the extent of the leg is up, I guess. Because it can decide to step like this. And this is probably where I would go diagonally. I mean, it can, you know, go pretty high up, I guess. Hmm. I don't know, weird. Because if I look at this, really what this means is this node, right, is determining how it can rotate, which this is not far enough now that I look at this. This internal angle needs to be quite higher. Alright, so fortunately, since I copied them all, that means all of them change. Nice. So my idea is that when I'm moving forward, I rotate this, like, I rotate it forward and say, all right, this is where you should, like, try to keep your feet at. What is this marker? It's just that. Also, the line is actually there now, so I probably don't even need... I'll just make this smaller, I guess. Even smaller. Oh, also this is kind of bent out a bit wrong. Interesting. Do I really need to turn on deterministic? Kinda sucks. I don't want to. I feel like part of what I can do is I can try to force these bones to start rotating back as well. Because I think all iterate does is it reads in the current position. Hey, Danilin. I think I missed that message a little bit. I think all it really does is it reads in the current angles. So I think I can change them each update. I can say, hey, this one's not quite at like the ideal angle. Let's try to correct that. I'm just pretty sure it saves time to not use deterministic. And it should make it look smoother in motion as well. Because there shouldn't be any discontinuities. This does also mean that if I have it slightly in the ground, then this can go down a bit, which it should actually be able to go down quite a lot. Yeah, this really does have like a huge range of motion. Remember that you can animate objects. Cool. That's what I'm trying to do. I don't know. I'm just trying to think of like... There's even this other thing that's like getting me now, and I'm thinking of like posture. Like, what if this isn't like sitting like this all the time? What if it actually decides to like stand upright like this and it walks at you like this? Right? Like what happens then? Can I make it do that? I could. I could make it do that. Like, this has so much motion. I should keep going with this. What I'm thinking of is just some, because you see how much motion you have here, right? Some sort of way I can set up a series of ray casts or something like that. Essentially have some sort of like, I mean, I already have a little bit of rigging where I just want these to rotate forward. But more just that I don't know. I just shouldn't. I just should keep it as simple as I possibly can right now, because this can get pretty complex, but also it's a lot of, I don't say visual. It's not really visual. It is going to be physics involved. Maybe shapecasts aren't correct. I would like shapecast because it gives a size to the legs. So this means it's not going to be trying to like push its leg through very small objects. This is essentially the, actually, yeah, if I really think about it that way, this is essentially the Minecraft's equivalent of checking the neighbor blocks and picking the best collision point, right? So if I really think about it like that. But then the issue with the shapecast is that this contact point with the ground is not going to be correct. It needs to go into the ground a little bit as well. It's got to be quite a long raycast. But it should also be that at the point of contact, it's almost like I need like some kind of spline raycast is what I really feel like needs to happen. It needs to go here, 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 and then like come back this way, because the motion range is more, you know, where is it stable? Where's the feet flat? It's like this. Right, it's like this sweep motion here. Like this is where the feet want to be. They want to be along this curve that I'm drawing out with my hand. And I don't think they want to be too far away from that, which a raycast just doesn't give me. A raycast can say put your feet down here, when it would be better just have your feet here, right? And maybe I can do that. Maybe I can just have a series of raycasts and I can hit the first one that hits. I start with one up top, like around here, and then I sweep down. You know, I so the raycast, it goes from here in, and then it goes from here to here, then here to here, then here to here. That's what I want, at least. Does the game benefit from that? Probably not. Definitely not, in fact. I think it looks just as convincing along this line. It probably looks just as convincing. Firefox removed the fox? I don't think they did. I believe literally yesterday I saw a graphic with like 3 foxes on it for Firefox. Start changing on social media. I want the sweep so bad. I want a sweep. I'm gonna write a neural network for this. I'm gonna make a neural network for my crawling spider bot. Alright. So middle left cast. This is the target. The target is just going to be set. This should be top level. Right? No, not really. This can just be moved to the collision location. Well, yeah. Actually, yeah. These should be top level. I will be setting that up here. All right, I think what I want to go ahead and do is I do have a need for leg pairs. So I think I go ahead and set that up. So I'll just create a script for leg pair, which should I? Well, okay, this isn't like the crawler bot category, so I guess it all works, right? Yeah. Leg pair, a resource, what a class name. We're going out, time to watch FNAF 2 with a friend. Alright. Enjoy it. I hope. Or laugh at it. Yeah, I'm gonna have to deny that one. I'm gonna have to deny that one. It's gonna have to be a denial on that auto mod there. 1984. Curly leg pair. All right, so the purpose of the leg pairs is that I can determine when a well, okay, let me go look before I continue with this, because I think this is a really good, I do think this is a good implementation of it to an extent. In a way. Because you do create leg pairs, and that is part of that. Does leg have leg pair? Like, I don't, this is a bit strange. Yeah, okay, where is the leg bear? Okay. Definitely not utilities. Surely not. It's gotta all be. It all has to be here. Where is it? There's literally a setup that's like hexapod, and then it says leg pair. Because you build it with the leg pairs. Okay, options, body plan, add leg pair, 0.1, 1.1. What? What? Root and rest. If it's front to back, so there's the forward leg, middle leg, which sits slightly behind the middle of the body, and back leg sits very far behind the body. So it's like the pushing leg. And then it looks like it's just that. Huh. Okay. So I thought I was defining as leg pairs, which I feel like I still want to do that because I want pair index and then leg index. Because you're always giving 2 legs. Sets of 2. So what I want to do is I want to give it essentially I'm just giving the leg targets. So I want to give it needs to have the ray casts. It needs to have the target points. And then I think it just needs to have these 2 nodes here for which these are the nodes that it will rotate for orientation. So this will be the left. I guess I'll just call it the left root, which is just a node. Well, yeah, a node 3D. I think it's node export. Okay, so I do have to give it a node path. All right, sure. So these are the roots, and then these are the pieces that move and rotate to reorient the raycasts. And then I have the actual raycast. Which are just going to be shape casts. Let me change these to be root left and root right. So I feel like it's probably better. And I'm going to require the bees be right. So should this be a resource or should it be a node? I mean, if I really think about it, this could be the leg pair node. That could just be the leg pair node. And then I can read through this list of leg targets. Let's do that. Extend node 3D. Root left. Shape casts and then markers. Let's change type to leg bear. And I can give it these, so root left. That, root right. That, cast left. Middle right, cast. Well, it should just be this one, but opposite. So 1.8642. Here we go. And I guess I can give this a name. So we know it's shared. And then my thinking has been that when I want it to walk up surfaces, I will use a cast from like here out to detect the wall in front of itself. But I can just use the exact same raycast. Just bring it back slightly and have it curve down. Why would people build this thing? People would not build this. This is actually like... Oh, it's just cool. That's really all it is. It's just cool, and that's all I need. I mean, I wonder if what I should really do is not even configure these like this, but just have like a transform for each of these. So for middle left, I'll just give a transform. For this ray cast, I give a shape. I guess not, because there's quite a bit to set up here, actually. Whatever. I gotta delete these markers. Let me give these short names. This is like just a little too much. Clutter, I think, for the eyes here. Yeah, that's way better, for sure. Okay. Let's keep going with the pairs. This is actually like better. This one can be middle. The front leg pair, this should be the front, right? Yeah, this should be front. Which I think I need to go one step further than this. Yeah, that's good. So this cast this here. Well, I guess each leg pair will define how far it can rotate when it moves, so that's kind of the point of these routes. But I kind of think I need to point the Z in the correct direction for these. Well, actually, you know, if I know that it's the left pair, then I know I'm rotating it positive. And if it's the right pair, it's the inverse of it. Or at least I think that's what it is. Okay, so if the left pair, it's opposite the rotation. Right. It's clockwise versus counterclockwise. I'm just not sure about this route. This route one. Delete that. This section just moves in here. There we go. Move it over there for now. So I can put this in the right place. $109.5. Yep. Yeah, I gotta take the dog out. I'll be right back. I'm back. Okay. Set these up. The dog is looking for something to bark. I can hear him huffing and puffing. He's running around. He just knows there's something he can go bark at right now, and he's looking for it. Okay. Okay, I've got leg pairs in. And now I believe this. We're looking for an array of these. Right, so that's what I would set up there. Now I have the leg pairs and I have those. So I'll probably make this a class. A crawler character. And then I guess I should actually rename this. Yeah, let me name this to crawler character. And I'm just gonna send it like this for now. Right? Which I thought I already sent the script, but I guess it didn't. Anyway, crawler character. Initial start there. Change some of the stuff like cast shape. Okay. So I have a shape cast set up. I guess what I should do is start making it so these leg pairs, when they process, they will make sure these targets are set to top level. And then it puts the targets where the raycast hits. And yeah, I mean, I guess for now that's just what it will do. I'll have it put the targets where the raycast land. So calculate ground force. This is where I check the result of all the raycasts. So I will iterate each iterate all of these. And then I say I check the collision for each point, and then I try to attach to that point. For now, I can ignore the root. I don't care about the root right now. The root's just going to be a node that I rotate and probably move, maybe. Just sort of like an orientation thing. Or like an offset. Because it seems like in both cases, to make it look better when it's moving forward, you shift the raycast forward a little bit. That was one thing that the Minecraft video didn't mention, but it was pretty obvious after it started moving that when it would move, the things would move forward like a half block or something, and they'd walk back when it stopped moving. So for each pair in the leg pairs, I guess you can just say if the pair cast left and pair cast left is colliding, then I will. So I guess I want to do this. Ensure targets are top level. This is just move targets to collision point. You know, I'm just not even going to do all this. I'm just going to assume that they exist. Because if you set up a like pair that doesn't have anything assigned or is missing something, that's a bug. Okay. Very simple now. So if I move it forward, I guess I will actually have it move back instead. So it's going to go over the ramps, or its feet are going to go over the ramps, and then we'll see what happens when it reaches that. Okay, I mean, it definitely did something. I'm not really sure why the raycasts aren't... The raycasts just aren't updating. They're just not updating. Which is weird. I don't know why they're not updating. They're just literally not updating. Oh, probably because they're not colliding with anything. Alright, I'll be right back. That would actually be why. They're just not colliding with anything. Back. Right, so none of these raycasts are actually colliding with anything, and I think this is probably where I actually just have to say these should probably all, the shape and the collision mask should probably be defined on Crawlerbot. Or at least the collision mask should probably be copied from here, right? So I should copy the collision mask for the rays, so they would collide with whatever Crawlerbot collides with. So I'll say that. I'll go ahead and make this a tool as well, so this will run in the editor when it happens. Copy. Yeah, so ensure targets are top level. Copy collision mask to casters. And then I'm thinking about the shape. I don't know, should the shape be defined here? I don't know. I may have I won't really, but I won't do that. I'm thinking about having it so like either Crawlerbot or a leg pair or something defines a shape that's to be used for the legs. But I may change the size of the legs, and then I'm like, okay, well now these two legs should be a slightly different size, so I'm not gonna mess with that because then I can see myself possibly wanting to change that, and then I've just created a kind of a silly abstraction there that I had to deal with at that point that I didn't really need. Okay, so it's weirdly not colliding. Because they definitely are colliding, but then it's like doing a weird thing. What is it doing? Target right, cast right, collision. Oh, what the? Collision point. That would make sense. Almost. Sort of. Not really. I don't know how I made that mistake, but it did. Whoa. Whoops. Yeah, okay, my mistake. That's so weird looking, man. I just that's hitting something primal in me looking at that. Okay, well, it's sort of going there. So now, honestly, I think I probably just send this at this point. Get staged. Added leg pairs. We have some setup. And then each pair is going to have like a rest length, essentially, where it says, I'm going to make all the casters act like springs. They'll all be capable of holding up the body to an extent. Like, I guess they'll be capable of holding up the equivalent of 2 legs worth of power. I mean, technically, if I'm making this like a scaled up ant, right? I think ants, the common thing is like 20 times their weight or something. Let me check that. I've got a bunch of tabs open here. Ant lift ratio. It's kind of weird because they say that they can withstand 5,000 times their own weight in force. But that's like the point at which they die. So, I mean, stack a car on a person, they can probably not die. But they're definitely going to be stuck there and probably not live forever. So if I'm looking for the lift weight. Yeah, it says 20. I'm seeing it 20 times. 14 times. $10 to $50 times. Yeah, it's more like watching an ant and see it pick something up and then be like, all right, I know how heavy that ant is. It's clearly carrying this thing, and then just take the thing from the ant and weigh it. And it's like, okay, this is what the ant is like naturally going to be capable of doing on a day-to-day basis. So it says 20 to 50. I guess I can say... I might say a single leg would be capable of like 4x the weight. Or whatever. So if I take the weight divided by the number of leg pairs, and then I multiply that... Yeah, take the weight, so the weight's like 64, divide that by 6, and then multiply that value by 4, and that's the amount of mass a single leg could support. That seems right to me. Anyway, as I said, I was going to send this. That's like... Okay, I guess... Okay, I don't have to sneeze. What is all this? What is changing that line? Parent ID path. Okay. What are those numbers? I don't know what those numbers are. I'll just be sending this. Oh, I will fix that. I don't need these on there anymore. Do these have it? Yep. They all have it. Okay. So new targets, I set up leg pairs, they have all their information. And then... Yeah, this stuff, okay. Should I actually call this IK character? I don't... Okay, I only want this for the crawlers. I want the other... Especially like a... I mean, I don't know. Hang on. I actually don't know. I think for character control, it makes sense to just use a single spring and force them to be upright, but only losing their upright when they have... when they do impacts or things like that. But I'm wondering if I should make crawler character extend legged character or something. Not extend it, but be called a legged character instead. So it is something that uses legs to move around the environment. Because that's kind of where I'm going with this. I'm kind of going with it being that each leg applies just an upward force if it's in contact with the ground. Using springs. I guess I'd also need it to be a pulling force too, which I guess it would be a pulling force. If the spring is overextended, it will have a stiffness back to pull itself into the ground. You know what I'm wondering? You know what I'm wondering? If I can make... Whoops, I didn't type that right. If I can make... Okay, good. Could the root actually be bound onto this point? And then that would mean whenever this bone rotates like this, the raycast will move as well. Or maybe it could be attached to this one. Also, essentially the forces... Oh yeah, the root is actually going to be the location where the force applies as well. So if the leg is attached, this will have some force pushing against root over here. So should a root be attached to that then? Maybe it should be. That will mean whenever the leg... I'm not sure. I'm not sure. That probably doesn't make sense. It sounds like it could work. Essentially, I'm still trying to go for that idea where this is like the raycast is like a swing that happens. So, but it really would be like a curve shape. I'd cast it forward and I'd, you know, do these steps like that. And I would say that the cast itself is the expensive part, but it's actually just, it's really just the distance that you travel is the expensive part. The more complicated your shape and the longer you cast it is what makes it complicated. So if I did have a path and I cast it along a path, it would really just cast it along shorter and shorter. It would do more casts, but they'd be over shorter distances. So it basically just comes down to like an intersection. Is there not something like that? Because, I mean, there's nothing... I shouldn't do that. I really want to, but I really shouldn't do that. I should just keep the raycast as lines. Well, I mean lines. They're spheres, so they can have thickness to them. Okay. Let me think about this. Calculate ground force. I wonder if instead handle input should probably have a call to like update legs first, and then I will do all my leg updates. And then ground force will just check to see if those legs have contact points, and if they do, yeah, I think that makes the most sense. I think I'll have handle input because in addition to this, I'll know which legs are attached, and I'll be able to determine if the thing should move or not. Like, if suddenly none of its legs are on the ground, handle input needs to know that ahead of time so it can decide maybe how it wants to move, or if there's any sort of thing happening. Or maybe just not. Maybe just handle input drops out completely from crawler character, and handle input would instead be, yeah, probably. Okay, so I'm gonna have let me think here. Because I would also really like to have it be able to walk over gaps in its path. Which I guess more or less means I do a scan ahead of like some sort of cone ahead of the leg. So I can say, all right, well, I have a gap in front of me that's colliding with something underneath, like deep in the ground. But I would just want to go over that gap. So if the position's too low, then we do some additional casts in a cone shape slightly ahead of it to find maybe a better location for the leg to go to. Dog, what do you need, Rat? You don't need nothing. You don't need nothing. You're all right. You're all right. I mean, I just need to start simple, really. So I'm just going to make it so that it will walk at this point. But I think I do need to have... Red, hey, buddy. Okay. You're okay. I need to have some sort of update for legs prior to this. So I think maybe what I can do is I could say in integrate forces, I could override this, call update leg function or something, and then call my parent class integration. Also, this one should probably be like, is this a Boolean? True. And then I guess this probably be a tool. But now I think that means if I have that set up for tool, then this... Okay, player doesn't fall, at least. Okay, so that's good. Oh, because player has a script that's not a tool. But crawlerbot does. Yeah, I mean, whatever. I just should make sure that's turned on. Because it should be turned on for these. Okay, so there's that. Yeah, I think what I probably do is I just override this. And I do update legs. And I could do super integrate forces state. I don't know if I really need this, but I guess it doesn't hurt to have it. So this will move up here. And then I'm just going to simply say, check each leg pair, and I guess what I can do is I can just say inside the leg pair, it should be like I'll just say is left grounded. Oh, what do they say? What's their leg look like? They have a touching ground. Can move. Is grounded. I mean, I guess the leg pair can update itself, right? This is probably something the leg pair should do. So I'll put this in here. I'll have a function. I just do that. Though I am already seeing quite a bit of duplication happening where I'm just writing the same code twice for right and left variations. So this is probably where I should actually just clean this up and instead make the assumption that I always have leg pairs. And instead it would just be sets of individual legs, which have a root, a cast, and a target. Which I guess the root just becomes the node itself, really. Okay, I'm gonna go ahead and rework that. So instead, this is the leg. So I'll just make it a crawler leg instead, and it is its own root. And then I just have the shape cast and the target. And now all this is that to crawler leg. I'll actually skip the rename for now and then rename it later. So yeah, now this is just a node 3. And these become crawler legs. Which I'll make this a tool so it can just load itself in. And it's just going to search. Yeah, they're exports, which means they should be loaded prior to being ready, I think. I think you get... I mean, it should happen at least. So, if not shapecast, I will look for my child. So... should probably be find. First descendant, pattern. I believe I'm just doing that. Recursive, false, owned, true, which I guess I don't even need that. Yeah, so those can just get loaded up. And then if I were to reload this scene, I should see it pop in. It did not pop in. Okay. How do you search for class? I thought this was like... whose name matches pattern. Oh. there's type. Okay, yeah, that's what I want. This is what I'm looking for. Now if I reload scene, bam. Okay. So it finds them right away. These are just gonna be change back to nodes. And I want to change these to crawler legs. Okay, they'll load once I refresh. Why does it do this? I was thinking it would keep the search, but it's just not. Alright, they're all set up. Instantly loaded. Now, leg pairs is going to be an array of, I guess it's not even going to be leg pairs anymore, it's just going to be legs. Ensure targets are top level, which I'm just going to do this. Or it should just be top level. Which, I mean, I guess I just do this. Okay. So there's that, and then copy collision mask to casters. So I have to really do there. Now update legs, we'll just do for, I can just call leg update. And then we do that. And then I can just say, check each leg, and I can apply, I guess I would treat each one. Well, okay, the update is actually gonna do like force calculation as well. So I guess each of the legs I would set, like, if I set it up as a spring, and I guess I would calculate velocity as, well, the spring's velocity is specifically its rate of Should I be calculating spring velocity as the rate of... Technically, velocity is the rate at which the spring is moving. Or at least the end point is moving relative to the fixed point of the spring. That's the spring velocity. Which is weird that I'm only just now noticing that. I've been treating spring velocity as the rate of this fixed point moving against its contact point. Which that is the same thing, right? But not really. All right. I think what I want to do probably immediately is I've been thinking about this, making a shapecast spring type, and every physics update it is doing some of its own force calculations. You know, it's checking where is its collision point now, where was it the last frame, what is that velocity, and then I can make it do iterations, which is what the actual spring thing does, where it takes that chunk of time that it's moved and it says, okay, well, let's split this into 4 pieces. Let's split this change into 4 steps and say, all right, at this step, we have, at the first step, we have this large velocity, this spring force, sum that up. This next step, well, and I guess it wouldn't even really sum it up because it can't do it over time, but essentially that's what it should do. It says this is our velocity, this is our contractions, this is how stiff we are, and this is the velocity that we just calculated, which is just the change between our global transform and the point of contact. Alright, I think I may want to go and set that up. And I guess I'll just put it out here. This makes it easy because I can just ask the shape, I can just go to the shapecast and say, hey, this much time has passed. What's your force? Or not even that, just literally ask it, all right, what's the force? What's your force? What's your damping? Not even that. I don't need to worry about damping or that. The spring says its force and damping, and then I ask, I tell the spring the stiffness and the damping, and then I come back later and I say, all right, spring, tell me how much force you're applying right now. And then I just copy that. Okay, so I go up here. I have these two things. I have a height offset, a spring stiffness, and a damping. I just copy those straight into here. And that's just a weird turn, but whatever. And then there's also the case that this is modified by mass. So whenever I'm using spring stiffness, I am multiplying it by this mass times 100 thing. So yeah, let me just say, this value is used to make the stiffness and damping mass independent. Okay. Okay, so it's just these two. Okay. Use contact length. All right, so this is some unique stuff here. This allows me to add some exception to it. And then use contact length. True. I mean, I guess what this means is I probably just look at that directly, and then I would I want this to remember, yeah, I want this to remember all right, let me just do a control F on Shapecast and see where I use it. Because that's the last call, actually, is right here. I guess Godot is colliding for these things, and I can still call ground and hit position. Yeah, I'll still use a lot of this stuff. And then I would do something like this. And then I say, I do the forced update. So just what it will do is it will say, using max length. Which I'm actually seeing, I am seeing some problems where where if I have an offset and it's not in contact with the ground, I'm technically saying, oh, it should pull the player in, but that's like an infinite pull. This is weird. This seems weird. I mean, I think I do just have some mistakes that I've made with this setup here, where I do need ground contact to even apply a spring force. Which, I mean, I guess I do here. If I was on the floor, yeah, I guess I don't even calculate a spring force. And I do zero it. So it does have to have... Yeah, okay, this is right. It does have to have contact to even do anything at all. Okay, so that's correct, actually. So calculate force just uses its current... should only be called when... I'll just say should only be called once per step. So this will take in I guess my last contact. And then I guess update spring will just say last contact point. How do I say vector3.in? Oh, cool. Whoops. And the velocity, I'm tracking my previous position every update. I guess I do this. Last contact length equals max length plus the height offset. Oh, and then I do have this weird thing where I have a desired height offset. So I guess what this means I have to do is probably just remember there's a certain way that Jolt does this where it keeps track of this lambda value, and this value is constantly being updated. Or constantly being summed up. So in one step, it'll calculate the distances. It calculates its essentially its change, I guess. How the spring has changed, and then adds that to its total force. Or I guess it adds the difference to its total force. So it'll say, all right, well, I should be applying 200 newtons. Last frame I was doing 100, so I add the difference. So now I say 200, and then I retrieve that value. And then later on it expands and it says, all right, I should be applying negative 100. The difference is 300, so then I add 300. It's kind of a weird way to keep track of it, but that's what it would do. I guess what I can say is I could do like update offset and provide an additional height offset. So it'll compute its compression. At that point, it computes its compression. I guess that actually makes sense, right? Update spring or calculate force. So I give it the step and then I give it a, I guess I can call this a bias. So calculate force just takes its current length that it's computed at, adds this. Minus length, which length is just going to be closest collision safe fraction. If it's in contact, and if it's not in contact, I use max length. Well, I guess I just don't actually use anything. I just say its length is at its rest length, which is what this would be. I guess this is also where when it detaches, if it is properly acting like a spring, that's probably where that like lambda tracking comes in, because then it says, all right, well, our force is 0, and we were applying 300, so now we need to apply like minus 300 to 0 out or something. That's probably what that comes out to. But I don't think so. So yeah, I'll just do I guess I don't even need that then. I just call it once per frame and then directly access total force. It's probably fine. But then I am using the contact length as a velocity. So essentially I take the offset and then the previous offset, then I use that change in length as velocity for damping calculation. Which I suppose can be like -1. No, I can't say -1. I guess I just say infinity or something. So if it ever is infinity, I guess I also do this, var. Well, I guess I would just use I would just say my length. The length value is my velocity, if last contact length is. Then speed. So if I could be -1, which is I'm compressing, or I can be +1, which means I'm expanding. Let me check what velocity is calculated as. So damping is spring velocity. So my normal and my spring direction are aligned. And then I multiply that by the difference between my linear velocity and my contact velocity. So I'll just say contact velocity is 0. So if my linear velocity is negative, which means I'm falling, then my velocity becomes negative, which means I'm compressing. So a negative velocity is compression, a positive velocity is expansion. Okay. So if my last offset was 2, my current offset is 1, this is a negative velocity. Means I'm compressing. So it's the difference between my last contact length and my current offset. So that just becomes speed. Otherwise, it's just my speed is just offset. Yeah, I guess it's just a negative offset. So if my offset is -1, it actually should just be offset. My offset is positive, that means I've treated it as an expansion that's happened. Negative is compression, positive is expansion. Okay. When slipping, the spring disables itself. Redirect gravity in the slip direction to prevent the spring from falling into the surface as well as slipping. So I compute a downhill vector. Okay. This can just be a modification to spring force. So that's kind of whatever. Max length minus length. So if my max length is 5 and my current length is 4, that's +1. Actually, that's +1. But it needs to be negative because it's minus. Yeah, because it's 0 minus the... I don't know why it should be negative. My max length is 5 and my length is 6. Or if the rest position is 5 and my length is 6. It's 5 minus 6, which is -1. So I should be pulling. Yep. So then, yeah, now it's just damp and spring are calculated like this. And multiplied by a normal in the spring direction. So I guess this just becomes... Is ground normal? Yeah, ground normal should just be exactly this call. Ground normal is collision normal 0, collision normal 0. It's never changed. It's exactly that. Okay. And it can only push, so the normals have to be aligned for a push to happen. This times speed. Also, I say spring velocity there. Because it's a float. So the velocity is the change dot or multiplied by the dot of the normal to spring direction. Okay. The smaller value between these two, and then spring force is this times the spring direction. Spring minus damp times the spring direction. Oh, and then I guess speed. I guess this actually isn't based on step, is it? No, because velocity, yeah, velocity has nothing to do with that. All right, so I just actually just provide a bias. And then... yeah, okay. Alright, well this all should be good. Is offset used anywhere? Offset is used just there. I guess I just call it spring cast, and now I take these out, and I'll just place those on the spring cast. And then up here, when I'm ready, I can do... Let me even rename this to just be spring. Okay. I mean, I guess I don't even need to call that. Springcast can call that in ready. Because these values should be assigned before ready is called. Okay, so I grab those. And then here's just some other some updates, and then I don't need these anymore. If you use contact length, otherwise it's rest length. I guess I can just say if use contact length, then I say that. Otherwise I just treat it as its max length. So it would actually just say, yeah, I'll just say here, if use contact length, then I do spring, calculate force, desired height offset. Otherwise it won't have any collision, technically. So I say treat length as max length, which just means I probably just do I can probably just do calculate force with a bias of 0, so I just treat it as if it's, yeah. Whoops. Calculate force with spring. Well, no, I think I just always pass that in. If I want it to do that. I think otherwise I say maybe this should be more like, also, can I not calculate up here? Because I don't change ground normal before this. I do calculate a ground relative velocity, but this is not going to be used anymore. I just need it before I get there. Say math trick's just going to go away. If you use contact length, then I just say I'll say spring calculate force. Otherwise, I think what I kind of want to say, like, I want a way to tell it to update, but not use I mean, it will just do this. If it's not colliding, we just say it's not colliding, right? But if it is colliding, then it's going to do this calculation. So use contact length here is so that I can change spring to just treat it as if it's 0 length. Which is more or less just me saying I just don't use it, really. I feel like I just do this is really all I do. And then later on I check if contact length is on, then I just don't set the force. I guess I can do this. I could do like like if this value is true, then I calculate as if I have no force being applied. So that's kind of what I want to do. I don't want to do forces if I'm slipping. So yeah, I'll just make this false. And I can just say if override collision or we're not colliding, then I consider it to be turned off. I think I'll just do that. And I'll actually change this value to disable spring instead. And then I just have to toggle these. So I'll just turn this on, then I recalculate it, then I may turn it off again. Okay, so it does happen to actually follow along with slipping, so I'll just turn this off. I'll just get rid of that. I don't need any of that other stuff. So then I just say, calculate force with is slipping. These just go away. That also just goes away. Ground, hit position, ground to normal. Updating it. I say calculate force. And then anywhere that I'm using spring force, I just do spring dot total force. Wait a second, what? Because I oh no, spring total force plus ground velocity times mass. Okay, that was we're good. We're good. All right, we're good. And I just can modify this directly if I really feel like it. This is stopping stuff. And then I don't have to do that anymore because I don't use that one. Okay. All right, so do the springs behave now? Does spring still behave? So what this means is I go to my player, and I change type to spring cast, an actual spring cast, and then I apply, I set that character controller is broken or player script is broken. Test if we can switch to the stand collider using the shape cast results. So I guess I just do shape cast not declare the current scope. Spring. Alright, just that simple. I guess I make this a tool. I don't care about that. Okay, I care about it for now. Just get rid of the warning. Okay, so now spring cast. And then in the spring cast, I now have to set these values that got deleted, so I don't think I was using the defaults. Maybe not. Just go find player. Player scene. It does have a height offset of 0.03. So I guess we'll write that in at least. 0.03. And then it looks like I am just using the default values otherwise. So it gets moved down there. Okay. And it did crash. Spring force does not exist. Okay, so I guess I just say spring dot total force. And then that's just what that does. Total force of the value of vector 3 on a base object of nil. Right. Right. Okay, so calculate ground force somehow needs to yeah, there is no spring now. Alright, so this definitely does have to handle the case when spring just doesn't exist. If spring and spring is colliding, otherwise we will return quickly. All in here is fine. Yeah, all in here it's fine. But then at the top I have to make sure I'm not using this. If spring if is on floor and spring spring is colliding. So then I just say here if spring and I guess I can compute this here, so I can just say like var I do want a way to have some extra force apply here. I guess I could use this like desired stuff. So I could say like desired like acceleration because I'm multiplying it by delta. Prior to applied to the body prior to desired motion. Right. Additional acceleration applied to body prior to desired motion. Right. So then here I don't really do spring force, I just say desired is equal to this value. So now should be running fine. The spider's gone. I don't know where the spider went, but interesting. Okay. So my spring is not updating right? Oh, it's because I don't update the last contact length. That's probably what I'm doing wrong. I mean, that should be what I'm doing. Okay, it's just falling into the ground. Ah. What have I done? What have I done? This could just be like... I mean, I guess I'm not really sure. I'll just do this and see what I'm getting. Okay, so I'm going to push up 50. Alright, so there's definitely some kind of mistake here. Alright, let me just print my offset. Okay, the offset's correct. Is the mass wrong? Maybe the mass is wrong. Because this number should be in like the tens of thousands. I'm assuming the mass is incorrect. The mass did not get set up right. So instead of character controller... Oh, it's probably because I do it in ready, but then I override this in player. Yeah, that's exactly what it is. Okay, now I'm bouncing infinitely though. Alright, well let's start. It's better. So this should be the right. What other prints do I have? Right, I'll just keep printing out the force, I guess. Well, I mean, I don't really need to print out the force. The force is right now. What I will print out is the spring cast speed. Okay. This number is definitely too... Well, maybe it's not too small. It's 4 centimeters. Let me see what the value I get out when I bounce up is. Okay, it just didn't open it. Or it did, actually. Okay, so I want to clear this bit. Stupid stuff. Alright, so I should hit the ground there. So the first input I get is negative 0.4, so this is my speed. It's my velocity, yes. Which means all these values are correct. So let me just see if... Maybe I'll multiply this by 50. Okay. Let me multiply this by 80. All right, 100. It is a bit odd. It seems to take a really long time to settle. But this should be a better calculation for... What? Why did I just start flying? because this wasn't updating. If override collision or not colliding, total force is 0. What's the bug here? I'm guessing the bug is that I guess I should be doing this, and spring dot is colliding. This might have been a mistake. Okay. It is it does seem to be really like not powerful enough or something. Seems to be not the damping doesn't seem to be enough somehow. So the speeds all look correct, but yeah, it may just be that I mean, I don't know, like I'm assuming damp and spring are just dramatically different values. Okay, there's no space between them. Interesting. Maybe I just do that and I get a space. Okay. Spring matches gravity. No damping. Alright, let me... over here, I'm going to walk into a step. Here. Alright. So, walking forward. So spring force says pretty much delete all the spring force on the first step, and then delete all the spring force on the second step, and then it doesn't delete all the spring force on this step. Okay. And then we delete a lot of spring force again, and then we delete almost none of it. Perfectly canceled out. Wait a second, am I thinking about this the wrong way? No, I don't think so. This is the minimum value. So damping essentially just won't add to it, but it can take away as much as it wants. Which is probably incorrect. Maybe? Is that wrong? Should damping just be the smaller value between these two absolutes and then multiplied by speed? Or I guess not multiplied by speed. Alright, let me just start with mass. Let me start with these both just being 100. And then I think maybe this shouldn't be a min. Maybe it shouldn't be a min at all. Maybe this part's incorrect. And yeah, I'll just do that and I will set up. I'll set these two to like a little bit higher for now. Yeah, I think it's just more that damp shouldn't be... Well, these are the same sign. Wait, no, I'm subtracting it. Hang on. Is that possibly the mistake? I'm subtracting it, so when they are... Actually, no, I don't know. Why am I launching? You know, I want to go look at really quick. Jolt's spring thing. Because I think this is how spring part works. I'm a bit confused. Thinking this probably needs to be clamped fully. All right, I'm multiplying these by the same value. I don't know, should damping not be greater than that? And I'm bouncing infinitely. I mean, damping is taking off some force, but it should be taking off like more force, right? Should I do like 2 times, or yeah, 2 times stiffness times damping? Because what should really be happening here is this should be like maximum damping. Maybe this is wrong. Yeah, maybe the offset's wrong, actually. Alright, let me print the offset instead. Because when I'm negative, the spring should be pulling me back. It seems like what's happening is this last frame. I'll wait till I detach. Okay, I'll use this cycle. Right. So I ended with a positive value. All right. So positive value happens when length is less than its rest length, which means we're compressed. I don't understand. I don't understand. This just seems strange. How this is behaving. Let's go to the top. Offset's positive. The value increases. It's increasing, it's increasing, it's increasing. Maximum contraction. Compression. And then it starts to become decompressed. Damping is a really low value through all of this. I guess because it's moving slowly. But then yeah, right before I detach, it's like half of it. So spring wants to push me up. Damping is half of that. How is damping half of that? Should it just be 200? I should just be doubling it. I was even thinking of multiplying it by stiffness as well. So I double this and then multiply by stiffness. Or I just multiply by stiffness. This multiplier, in fact. It settles here. It does seem to really struggle to settle, though. Seems to really struggle with settling. And I'm assuming walking upstairs is just gonna, like, launch me. Yeah, pretty much just launches me. I think this is still a better calculation for speed because it should be accurate. Because speed is just the change in length over the last tick. Oh, that's why I need bot. Oh. I actually understand it now. I definitely do need step because if I change from 1 centimeter to 2 centimeters, that's not that's not saying I have a velocity of 1 centimeter per second. That's saying I have a velocity of 1 centimeter over this last tick I just did. So, in fact, I have speed over step. Okay, this was what I was missing. All right, so this should hopefully mean I now go back to just times 10, and maybe I need that minimum value back or something. All right, 2.2, 100 mass, 10, and it works, and it's not gonna work because infinities. Okay. So when I calculate, I have to provide the step. There we go. Totally settled. So it probably is the case that I may need more damping, or also it seems like I just launched there. That's not very good. Yeah, okay, that's not very good. So what was that? So I read out I'm not really sure. All right. This is probably where I bring back that min thing. I'll just bring that back. And speed is actually correct now because we're dividing it by that. Okay, so I still can launch pretty hard. Okay, so what happened is I hit this. Damping is always greater, and then damping is really greater. And then I have had one more kick of that, and then 1,000, and then it matched. So really, if I look at the result here, I'll just print total force. Okay, so this is too much. Is it the wrong order? Maybe it's just the wrong order. Maybe I do just have damp in the wrong order. Because this wants to push me up. I've contracted. But damp should say... Wait, oh, speed is an absolute value. It actually doesn't care which way it's going. My bad. Speed does not care which way it's going. It just cares about the difference. So... this should be just the absolute value. So whether I'm expanding or not, damping is a positive value against my speed always. So it should always be positive. That was strange. That's really weird. It's a really weird happening now. It's a really weird happening now. Once I start compressing, it stays compressing. Yeah, this is weird. This is just weird. Yeah, that. What was that? Maybe it's not meant to be absolute value? I don't know. Damping is just supposed to slow it down based on its speed. But I guess the question is, why is it so high here? Because essentially, spring compresses and says, all right, we want to compress. And then damp is like, all right, well, we're moving this fast, so let's take off some of that. It becomes stable. Spring says, okay, we're applying this, and then this one says we're not moving at all. So it uses the minimum value, which is just 0. But I'm seeing here continuously it's printing out the same value. So I don't know, I guess I need to print speed too. And see what speed is becoming, because apparently it's not correct. Okay, so we already fell. No, that doesn't seem right. How do I get 43 out of this? How do I end up with 43? What? I cannot be traveling 43 meters per second after falling literally not at all. That's just not possible. So I have a displacement of 0.04. Am I supposed to be multiplying it by step? If I displace by 1 meter and my step is 1 second, then it's 1 meter per second. If I displace by 1 meter and my step was half a second, that would be 2 meters per second. So it'd be 1 over 0.5, which would be 2. So I should be... right? So it is dividing it by the step. Okay. I am dividing it by step. My first offset is 0.04. .04 over 1 over 60 is 2.4. Yeah, so this definitely somehow is not correct. Oh, last contact length. No. Yeah, no, this should just become that. This is probably my mistake. All right, there we go. That's a better number. 2.4. And then always if I'm not colliding, then I say infinite length. Okay. So first impact is correct. But then I say to take off all of it, which is kind of crazy to think about. So this would be mass Yeah, I feel like 2.4 cannot make it that large. And the fact that it has to be like 0.19 and it's barely smaller is weird. Damping is like a lot larger value than it should be. I guess let me print out cosine theta. Yeah, it should just always be 1. Alright, that's correct. Yeah, I don't get it. Let's print damping. 2.2. I don't understand how 2.2 times, like, what? Alright, I'm just gonna print them all out. I'll just do this and then I'll do... I just seriously cannot believe that this number is that large. It's like always really large. 5,000? It's a huge number. 100 times 10 is 1,000. Maybe I just take off the times 10, I don't know. But then it's like, I guess the damping, I mean, I guess that's what it is, right? The damping is like totally preventing it from compressing. Maybe I just take off the times 10, I just do mass times damping. Even though I have infinite of this, which just sucks. Oh, that's so annoying. All right. I mean, maybe what I'm really looking for is damp is just a multiplier to spring instead. So or maybe yeah, because I think damping just kind of isn't right. I don't have the right model for this. All right, let me take damping off entirely. Let me hide these prints. And I'm just going to print out spring. Let's just start with no damping. Right, so this is already a mistake then, right? I'm like accelerating forever. Right. I think essentially spring starts as, right, at the simplest state, it's just how much force does it apply per like centimeter that it's pressed, right? Um, I don't know, is there a difference between like chopping it up? Does that make a difference? Like would I apply? I take the difference that I have. I guess I'll just see. I guess I'll just see. I'll just print out spring. Um, and instead, what I will do is I will say, I'll just do four splits and say I apply um I mean, it really shouldn't, right? Like, that just wouldn't make any sense if it did matter. It's definitely more the fact that the... Yeah, this just shouldn't matter at all. But I do still have the problem that, like, I'm not dropping the player. Like, the player's on the ground. The player's, like, literally in the ground. And he just starts accelerating. Like, immediately he's just accelerating up. That doesn't make any sense. I don't know how that math is coming out like that. Like, what's wrong with the spring? I don't know what's wrong with the spring. I'm starting from a standstill. Like, I'm literally just starting from a standstill, and it's, like, slightly compressing. Okay, so there's 10, but 20. And why is it just suddenly different, too? Why is it actually just suddenly different? Maybe if I consider the spring force as... I mean, I would also prefer damping to just be on a scale from 0 to 1 as well. That'd be nice. I don't want to have to type in like these weird things. Like damping shouldn't be more than that. I should have like 0.8 and that's that. So what do I miss here? Like it should be that a value of 1 does not prevent the spring from reaching its desired length, but it should mean that it approaches it. Like as it gets closer, the damping gets stronger, right? Or something like that. I don't know. There's a term that I keep getting in that keeps popping into my head that's like part of Jolt's thing. Like, should I use this? Like they say that 1 becomes like critical damping. What does that mean? So it'd be 1 over... I can just ignore delta time. 1 plus delta times stiffness. But then bias is actually the... Wow, like I must be doing something wrong here. Also, I wonder if I should even be considering the angle, because the angle is not considered in other places. It's not considered in other places. Maybe damping says maybe it's like for each I don't know. Depending on our direction, not even just speed, but like direction. I guess also our speed. I guess should be multiplied by speed. I just think there's some connection between the current offset and our current speed. That could say something like, or our change in speed relative to the length. So if we do like some maximum compression of the full length and damping is 1, then damping should take off all of whatever the spring wants to apply. But if our velocity is 0, then damping will take off anything. And maybe it's more like as our speed approaches like an overshoot. So if our speed says, all right, well, we were expanding at what would it be? Speed says we're expanding such that after one more step of this, we're just going to assume that our speed is going to be the same for the next step. And that speed is going to leave us at our desired length. So I say, all right, if my damping is 1, then that means I actually want to take off all of the spring's force. We're just going to assume that we're going to reach it on the next step, because most likely we will. So maybe damping is just meant to be like a multiplier, depending on the difference between offset and speed. Some kind of calculation like that. So what does this mean? This means that so my offset wants to approach 0, right? That's like the ideal. My offset wants to be 0. So I guess I can say, if I take my offset and I apply my speed again, which I guess at this point I would take off this step. This step doesn't matter anymore. So I'll just ignore step. So if my which I guess now speed does have a direction to it. So if my last length was 0.8, my current length is 0.4. That'd be 0.8 minus 0.4. Right? 0.8 minus 0.4. So then I would say, all right, if I take that speed and I take my offset, and I subtract my speed, that's where I expect to be at. But then I also need to say, like, what if I overshoot that? What does that mean? Because at that point, my damping should say 100%. I think I want to do a better thing. If my current length is 0.8, if my previous length was, or let's say my previous length was, I guess, just 0. My current length is, or I guess my offset is 0.4. That means I have compressed 40 centimeters. So my spring force wants to, so my speed in that case into the ground would be negative 40, right? Or negative 0.4. My stiffness calculates, whatever. And then I guess I could say, all right, if I were to apply this force, where would that leave me, I guess? I don't know. This is annoying. It actually is annoying. How I should be calculating damping. But I want one to essentially say, like, some kind of like perfect spring where when it starts compressing, it will slowly start applying force, but then as it's decompressing, it will essentially settle itself instantly, is what should happen. It should try to settle itself. It'll apply, so it won't do any damping while it's compressing. And then once it starts expanding, it'll do a ton of damping to stop itself. If it's expanded, if it's too large and it needs to come back, it'll be the same thing. It'll be like boom, like this, right? So if I point, yeah, so the offset is positive when we when we are compressed. You know, I kind of want this to be like not that way. I think I'd actually like to flip this around, because otherwise it just feels like, if I say 0 is here, and my mass is standing above the spring, a compression should be a positive value, and expansion would be a negative value. Is that not already what I have? No, compression would be a negative value, yeah. I'm just going to change this around. And this is the difference. And then I would just use spring direction, which spring direction is the direction that force is applied in. So yeah, I just use my negative offset there. Okay, now I'd like to print offset. I am gonna stop printing spring though. And I will just raise the player so I can see. Also, is this like a perfect mirror? Not I mean, it's maybe close, but not exactly. Okay. Essentially what I'd want to see is once we're getting about to this point, whatever my spring is at, I also consider my current expansion rate. And I should say, all right, well, we need to take off some percentage of that because we're about to move too far, right? So I'm just going to start, I guess, talking my way through it here. So, compute expected offset in next step. I would like to do current offset plus speed. So I print current offset, and then I would expect to go to next offset. Just gonna make this. Am I correct? Okay, so it's I'm computing the previous one. All right, so speed is offset, and I guess this should be offset minus. So am I correct? These are my expectations. This is what happens. Am I correct in the other direction? I think I'll be at 0.26. I'm actually at 0.25. I think I'll be at 0.22. I'm actually at 0.21. Okay. I think I'll be at plus 0.06, and I'm off the ground at that point. So I'm actually incorrect, which is interesting. So I guess what I should really be doing is saying my offset plus my speed plus, I guess, whatever I would be about to apply now, perhaps. So maybe this could be spring times that. Maybe this is a better prediction. So I want to see myself be exactly correct, and I'm not correct at all. Okay. Maybe it's just meant to be this. My offset plus... I mean, I think this is like actually correct. This is probably what I'm looking for. Okay, it's not what I'm looking for. Okay, so I mean, I don't know, I guess I'll just do offset plus this and see if I'm just not correct at all. So maybe it's just meant to be the negative of these values. It's probably better. I mean, I feel like I'm pretty close, I guess. But also I think what I really want to see is I want to look at I mean, it is a really close prediction. It's only I think it's only really wrong because of what the hell, these are exactly perfect. That's just the same number. This is off by quite a bit, I think. This is off by quite a bit. What was it like really correct one time? Why was it so correct one time? But I guess this is like over counting, right? So what I want to say is I want to say plus that speed, but then I want to say I can subtract what I might be applying from spring. So spring times, I guess this would actually just be, this should just be spring times step over mass. Yeah, okay, so that's wrong. Definitely just meant to be these. Because my speed is actually positive, because the spring is compressing, it's moving up, technically. Or I guess it's not really like that, it's moving... What did I say? Yeah, negative is compressing, positive is expanding. My speed should be negative. But why is that? My last offset was 0.8. My current offset is 0.4. Or actually, let's say it's negative. My last offset was negative 0.8. My current offset is negative 0.4. I have a positive speed, which would only happen if I did the difference between the two. Why am I so stupid? If I was at 1 and now I'm at 2, my speed is plus 1. That'd be 2 minus 1. If I was at negative 1, or if I am at 1 and I was at 2, my speed is negative 1. Which would be, if I am at 2, current minus previous. It is current minus previous. Okay. Alright, so I'm compressing. Speed says negative. I went from 0 to 0.5. I guess I actually went from 0 to negative 0.5. So my speed went down. Okay. Positive speed when I'm expanding. Okay, good. Good, good, good. Let me do a full bounce. Okay, there's a full bounce. Right. So if I have offset plus speed, okay, that's correct. All right. So there's my prediction. Offset plus speed. And I guess plus whatever I expect to... So if my spring is the opposite of my of that. Okay, okay, okay. Is this a good prediction? So what I expected to... What... Yeah, this is odd. Why is the value getting larger and larger? I mean, I guess is the expectation if there's no force opposing me. So I guess what would happen here is I would predict I would say maintaining my speed and then adding on what I'm about to add on. I would be 0.02 over. So I want to try to reduce that. So that would mean, I guess, sort of subtracting, converting this value now to like some damping value. And then multiplying it. Essentially compute what reduction do I need to spring to make it so that my expectation is going to stay at 0? And that would be my reduction. And then I multiply that by damping. So 1 would mean if I think I'm going to fully expand, then from this spring calculation, then I want to, I guess, not do anything, right? This is really close. So I would actually do very little damping here because I'm pretty close. But if it was 1, I would subtract off. I would get whatever force this is. Okay. So what I want to do is I want to compute damping force needed to set next offset to 0. So basically, if it's negative, then I don't need to do any damping, right? So it's literally just this value. So if I assume that I'm going to overshoot by some amount, then I need to say, essentially this is just a subtract, I guess. Or I guess I'm just put damp right here. So it thinks I would overshoot it by this much. But also this could be wrong. I mean, in theory, it could be wrong. Because this doesn't account for gravity, I suppose. I mean, this is the term that I'm looking to reduce, right? I'm looking to take spring, the value of spring times step over mass. And I want to subtract whatever I need to so that after it's multiplied by step over mass, I gotta take the dog out. I'll be right back. And I'm gonna get food while I'm gone, so I'll be back with food. I'm back. I forgot about my basic algebra. If I want next offset to be 0, well, really what it is just, I'll write it like this. Want 0 to be equal to offset plus speed plus spring minus damp times step over mass. Okay. And now I would just need to reorganize this so I can get everything on the other side. So I guess I'll just start by saying, moving this term to the other side. This will be 0. I'll just write it all out. Offset plus speed. So damp is the value that I want to be computing here. What can I do with this? I can think of this whole bit being over mass, so I can multiply both sides by mass. So I end up with mass on this side. Write it like that. And then I would like to divide by step. So negative spring minus damp mass times offset plus speed. This whole bit over step. And I guess I can like technically multiply this out now. So this would be negative spring plus damp. You can just think of this as being negative 1 times that. Right, so if you factor this out, you want to put the negative spring in a positive damp, which is good because I would like a positive damp. And then I'll just add spring to both sides. So damp will be equal to mass times offset plus speed over step plus spring. Let's write it like this. And since I know how the order of operations is going to go, this multiply will happen before the step, but it doesn't really matter which way it goes. Alright, so I'm left with this. I'm left with damp equaling spring plus mass times offset plus speed over step. So, I'm not really sure why spring appears here though. This is weird. the fact that spring is here. This part seems good, right? But it's a spring plus. It's weird. It's just weird. Bring all this back. I want my next offset to be 0. But the spring being there is just really, it's still a bit weird. It's a little bit weird. Spring plus, and this would be subtracting from spring, right? So this is my desired offset 0, my current offset plus the speed I'm traveling at, plus spring minus damp. So depending on whatever I've computed spring to be, means offset is going to be spring plus this value, which I don't know, I guess I just say I'll print the spring and then I'll print the damping. And I'll see what damping is coming out to be. Just comment all that out. Whoops. Like that. Damping is 173, damping is 650, 1000, 1000, 1000. So then this is the first time damping is higher. But damping is also never... I mean, yeah, it is supposed to be a subtractor to it, right? Okay, so I guess let's just see what happens if I do the smaller value. Damp is not the smaller value between damp and spring. And then I just do spring minus damp. Okay. So that's supposedly critical damping, by the way. That's what a value of 1 would look like. Which sucks because it's just not correct. This should be stabilizing really quick. Really? This never stabilizes. But I mean, I computed it like... Ideally, did I not? Like how? How is it this bad? So what am I missing? don't think I did miss anything. It's just incorrect. It is just incorrect somehow. I don't understand. Hey, Dallin. I just wish I could have the stupid ass spring. Why can't I have the stupid spring? Why can't I have the stupid spring? Is multiplying by the step incorrect? It's a force. But there's no step here. Unless sublinear velocity step multiplies this by step. It doesn't do any delta. Okay, so maybe this is where, unless lambda is multiplied by delta then? Maybe? Bias. Spring part get bias. Softness times lambda plus bias. Effective mass is a reference. Get bias. Is this at the top? Yep. Mass doesn't exist here. In bias. Wait, can I not? Why would I not be creating a spring? I'm already on the page. I mean, it'd sort of be like a slider 3D, but I have to connect that to two bodies. I mean, I guess that's technically what I can do. But I think the problem is one of them would have to have no mass, which probably makes it problematic. Because then it probably just wouldn't work. And it might always be weird. And this doesn't give me an offset either. This doesn't... Okay, so I can't. Why am I looking at this again? is. I scrolled through all this and I did not find the suspension. That's brake force. This is friction. 1 second. I'm back. I don't think any of this is... This is all engine, wheel turning stuff. Wheel update. Which is right here. Wheel update. No. Suspension. Okay, so it is not in wheeled vehicle controller. Unless it is. And it's secretly written here. Suspension impulse. I don't see it there. Yeah, this just... Oh, hang on. Solve. I believe the longitudinal part is a spring part. I think they're actually both spring parts. Probably. Yeah, they're both axis constrained parts. Forward and backwards and slip. Okay, so that's not it. Suspension part. Get suspension lambda. Okay, where's that updated? Okay, M suspension part needs to be called with something. It's all a vehicle constraint. Okay. So I've calculate constraint properties with stiffness and damping. Value of the constraint equation. Length minus max length minus preload length. So there's C length minus max length. Do I do length minus max length? Ah, good. So that is C, stiffness and damping. Calculate constraint properties with stiffness and damping. I give the stiffness, I give the damping, I give C. And that calculates constraint properties with stiffness and damping, which is a constraint part. Calculate constraint properties with stiffness and damping. In bias. Anti-roll bar impulse. I guess bias is how much to take off of that. It's the fourth from the last. So I guess that actually just means 0. So 0. Bias 0. Calculate inverse effective mass. I guess I'll just check what that really does. I'm pretty sure it's just going to give me... I mean, I'm just going to assume that the other thing is... whatever, right? I don't really need to know that. Templated... stupid stuff. So if type 1 is dynamic, which it will be, it's just inverse effective, it's just inverse mass plus, I guess, the press. I mean, it's literally its mass. Plus, I can't even decipher what all that means. Inverse inertia plus UX axis. I don't know what that is. Crazy stuff. It's just the inverse mass. It's just always going to be the inverse mass. I mean, I'm sure what this is supposed to be doing is accounting for inertia. It's just so weird. This code is really weird. This is literally just to say 0. But then there's like 2 lines here for... Okay. So it provides this, 0, C is the offset, which is negative. So if the length is 1.1 and the rest length is 1, it'd be positive 0.1. Make this shorter, it'd be negative, right? M effective mass. This is what I want to understand. Calculate constraint values with stiffness and damping. M effective mass. So at the end of this, this is like the out mass. Sorry. System. That whole spring part. And it saves the effective mass to itself. Right. So now suspension part has this like effective mass thing. The solve velocity constraint is what it calls. Does this use effective mass? It does not. Seems like it's only used. Calculate constraint properties. Calculate constraint properties. I'm looking for where it's red. That's an out. That's an out. That's an out. Out. Not reading. I guess it's reading if it's active. Solve velocity constraint, get total lambda. Is this what I've missed? It just got really bright. That's whatever. This might be what I missed. The M effective mass here. Now I am reading it. Which is just the same thing as mass, in fact. But here it does change. I think that change is only used in steps, perhaps. Dude, what is this? Super harsh light. Okay, I gotta fix that. 1 second. Nope. Jeez. All right. Calculate spring properties. Stiffness and damping. We just invert the inverse mass. Calculate spring property, or this is calculate spring properties helper, which does this, which will change that, so it adds the softness factor. It adds this softness thing. And then, so that calculation happens. Then back out here. It does solve velocity constraint. Templated solve velocity constraint. Get total lambda. And this is where effective mass was previously written to. Okay. That might have been something that I missed then. All right, let me see if I can do this, because the part where it's stepping shouldn't really, like, that shouldn't necessarily make it broken. Right? That shouldn't, like, make it broken. All right, this like, and I mean, maybe that's part of it. Maybe the account for, like, how much force is actually being pressed onto the thing is kind of wrong. Or what I've done, where damp needs to have some additional, that inverse effective mass thing, right? So, okay. So let's do this. I calculate force. I don't actually need speed anymore. Yeah, I'm just gonna take these out. And then cosine theta, I'm just gonna so that'll just be the last step. All right, I'm just gonna step through this. So the first thing that we do here is we calculate the properties from a stiffness and damping. And then I also technically have a effective mass calculation. Right, so we get up here. So delta time, bias is 0, C is the offset, so the softness is 1 over what's the step times damping plus delta times stiffness. This would just be delta times stiffness times softness times offset. Nope. What's the problem? Bias is already declared. Oh, okay. I guess I'll call it M bias. And effective mass is 1 over what? Is there a way to simplify this because of these two 1 over 1 overs here? I don't know. I'll just leave it like that. That's whatever. So this out effective mass then comes out to solve velocity constraint. Which actually, it appears like it's factored in the delta. Because it is multiplying by step. So it seems like this is already factored in. But mass is not factored in. So mass would have to be factored in. So I guess at the end of this, I say my force is going to be divided by step. So solve velocity constraint, get total lambda. I think this is because this runs in smaller steps. So really I'm just doing lambda. And this is what I have. So this would be JV is just the difference in acceleration. So actually this is the case where I do want this. I do actually want this value back. Because I can just compute the difference here. So if is finite last length, it should be whoops. Whoa, stop. So speed here would just be offset, and speed here would be offset minus last length. Last length becomes offset. delta doesn't exist, it's pulled step. Alright, so this is my JV. That's my JV. This is velocity difference. So world space axis, I believe, should be pointing up. Dot that with my linear velocity. Let's say my linear velocity is negative. If type 1 is not static. So if I'm falling down, it'd be negative something. So it should just be that. Speed minus get bias. Total lambda, m total lambda. Get total lambda. Velocity constraint. So I actually start at 0. So this would be really spring part get total lambda 0. Get bias. It's just softness. Times n total lambda plus bias. But bias is... This is where C is factored in. Yeah, this is the only place that C is factored in. Oh no, can I just iterate this in place? The difference is that C will stay the same every time. C would not change. I mean, I guess actually what I could do is just pretend like C is changing over time. So I could say they're moving against each other at the same rate, but then I just drop C or something. Is that what I figured out? That I can't do this because the lambda has to accumulate? Because otherwise... Get total lambda, apply lambda. don't know, was this what I missed somehow? I didn't account for softness in the effective mass. Effective mass times speed. I mean, damping is here. It's the fact that this bias term, this is M bias, which is not actually used, or that is only used here. But if in total lambda is 0, which initially it is 0, what happens is we take the difference here, and then we save that difference. We save the change. Yeah, because I'm pretty sure solve velocity constraint comes in as like, are they, wait a second, that is a velocity step, right? If I look at physics and look at velocity steps, it's right here, 10 velocity steps. I guess that is actually 10 velocity steps with 2 position steps. Maybe that's part of it. Maybe what I do is I take in, I could actually do that. I mean, maybe I can do that. Because otherwise this definitely isn't correct. It needs to have, at least in that case, it has 10 steps where bias and total lambda can shuffle around or whatever. Or total lambda can shuffle around and have some result. Because then what happens up here is we are continuously updating their velocity in this way. The spring is continuously updating the velocity. So maybe it's more the fact that when I do calculate force, I have to actually give the state so I can modify it over time. Maybe that's what I have to do. Because then I would be changing the velocity. And because the velocity is changing, that's my speed, is what this really means. That would be my speed. But it doesn't really work that way because, yeah, it doesn't really work that way. Because I've already built up velocity. Or maybe I haven't, I don't know. mean, I don't know, maybe I just see what happens if I just try it without doing any of that. It'd be softness times... Oh wait, this would just be 0. So softness is... Oh, this doesn't do anything, so it'd just be bias. Get bias is... just bias. Speed bias and bias. I misread that. I actually definitely just confused myself really badly and misread that completely. Alright, but here's lambda. Lambda is now solve velocity constraint on this axis with this lambda, which should just be lambda times axis, I believe. Lambda times inverse mass times axis. So yeah, I just totally misread that. Okay, let's see what happens. I slammed straight into the ground. I mean, I guess in theory I just keep increasing. Well, I mean, I could look at force too. +6. It did start as negative though. Which is weird. Because that would mean it's pushing me into the ground. Yes, just slowly increase it from here. Okay, it's not... Oh, wait a second. What, am I doing this wrong? Here's effective mass. Let me print effective, because this isn't really making any sense, the values I'm saying here. Okay, effective mass is 0.42. That's not right. Really? Wait. Really? No, that's gotta be wrong. Yeah, that must be wrong. One over the inverse mass. 1 over the inverse mass plus softness. Huh? Mass is 100. Okay. What is softness? Am I providing step correctly? Step, height offset, and then, yeah, okay. Softness is 2. So whatever. This just can't be right. That just doesn't make any sense. Or is it? because it's looking like I have to provide a huge, and a very, very large value for that. I don't know, let me do 0.5 damping. Yeah, didn't change like anything at all. Why is that so insane? Because this is a force value. This is supposed to be multiplied by step and then by the inverse mass. But I didn't expect effective mass to be such a ridiculously small value. Because it's 0.42. Effective mass from 100 to 0.42. Let's go 10,000. Yeah, this has already got to be like wrong. There's no way this is right. 10,000. How am I doing this wrong? Inverse effective mass. That's just crazy. There's no way I really have to go to 1,000,000. Yeah, there's definitely a mistake. 100% there's a mistake. But this is what I don't get. How is that wrong? 1 over mass. That's the inverse mass. Just 0.1, 0.01, plus a softness of this. Like, oh wait, is this already deltaed? Oh, I think it's a problem. This is actually already deltaed. That literally is the problem. That literally is the problem. This is supposed to be deltaed because it's already deltaed, so I need to stop it from being re-deltaed later. Okay, now this is probably gonna send me like flying into the stratosphere, so I'll bring this back down to like 10. Okay, that's already a better force. 6, 100, 1,000. And I think typically you would multiply this by 1,000. So I'm just going to say anywhere that I use stiffness, I'm going to multiply this by 1,000. Because what it's meant to be is like per at least the way I understand it, is essentially per unit of offset, how much, or per millimeter, I guess really is what I would be thinking of. How much force can it apply per millimeter of compression? And I believe there are 1,000 millimeters in a meter. Yep. So this would be like multiplied by 1,000. So I just start at like 10. I can't tell if I'm falling or not. Let me go to 2. There's not enough to lift me. 3. The damping being 0.5 is suspicious though. Now I don't like that because it looks like the same thing is happening again, where it's just I'm just bouncing forever. Is it my speed is wrong? What if I inverted speed? I mean, I don't know, maybe this is better. It's weird. Why is it on the stairs this happens? Huh. What is going on? Yeah, why would I bounce like crazy there and then I... What? This is so strange. This is not making any sense. I mean, I guess if I compress, that's like a negative point something. Then my speed is that value. My last length is negative 0.5 and my current one is negative 0.1. Negative 0.1 minus negative 0.5. I'm at like negative 1 minus negative 0.5, which is also be negative 0.5. So I think speed is right. But I mean, it definitely has this odd dropping effect that's happening. Like I drop too much. Like once I pushing up, it looks fine, but then dropping is like going the wrong way around. Yeah, I mean, let me look at this in slow motion. Alright, what if we're at 1? But is this even doing anything? I'm so confused. This is literally doing anything? Alright, when I set up a wheel suspension part, they use frequency and damping. So let me check what frequency and damping is. So this would be frequency damping, right? Really? Copy like that? Okay. I mean, I guess I know what this is. So I can just do this is that. Whoops. Okay. So what would be times, so this would be 100 times that, okay? So we're looking at 8,800. For this. 8,800. So it'd be like 8.8. And the dabbing was 0.5. But then this did a different one, which would be 2 times mass times damping times. Okay, so it'd be 942, apparently. So I guess I'm also doing... I guess this is also supposed to be multiplied by 1,000 or something. Interesting. Am I losing speed? Seems like I'm never going to be losing speed. Okay, so if I went a little bit higher. A little bit higher. Alright, now I'm just launching. Okay. So, what is going on with this? This is just the most confusing thing ever. Like, sometimes I totally just launch. And his effective mass still just like super weird. Yeah, it's always that for some reason. Alright, what if this was just mass? Okay. That's why we use the effective mass calculation. This is all just so dumb. I've forgotten why I was even trying to do this. I mean, I think I just thought that I could figure it out finally, but I just don't know what my mistake is. I don't know what the mistake is. Eight 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 2.64. $942.5. Like, there just is a problem here, right? Right? There just is a problem. Is the problem really that it needs, like, these extra velocity steps in the middle to figure it out? Should I go and write up My own Jolt character control that uses this kind of spring thing. I really don't want to. I really don't want to. I just wish it was in there already. I just wish it was. It's really weird that it's not spring specifically. I get everything else, but I don't get a spring joint for some reason. That's not an option. All right. I am status. Okay. So these are the calculations, which which the thing that happened was my velocity stopped being correct. My velocity was wrong. Because I would calculate the contraction as my change in length over the step, and I'd say, okay, here's my velocity in the last step. But that's like, that changed how it behaved dramatically. Right? Doing the velocity calculation like this was fine. And in fact, just falling on the ground should be the same. You know what I think it is? I think this was actually saving me a lot. Because when I walk into a wall and the spring suddenly contracts like a huge length, it would say, oh, there's actually like no velocity because we were at like a nearly 90-degree angle. That might be it. Because then I would just multiply that velocity, that speed that I computed, by the angle that I'm running at. Okay. So this. Which I guess I can actually just do up here. Okay. I clicked in var cosine theta and then I hit control V and I hit just some other key. I don't know what I hit. And I deleted that line. Okay. Okay. mean, really, that should already be accounted for as well, because I don't know. The speed technically is. Because if I fall like this and I hit the ground, the spring would contract up really far, but in like a short step. So like landing like this would like launch it that way because it just had a huge velocity. Oh, well, I guess the velocity is part of... I guess that's actually reducing the damping when I do that. Go back to these values. Spring is mass times 100 times stiffness times offset times normal. Then damp is the smaller value between mass times 10 times damping times speed. And speed factors this in. Large, 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 small. But it should be 1.5 and 2.2, yep. So spring velocity is normal times spring direction, and then that'll be negative. So when I compress, I mean, I guess I can print the speed and see what the speed says. Which is definitely, I mean, I guess I didn't fall for a full second. Why did it increase a little bit? Why did it go up to 2 and then... Weird. Okay, so which one of these is becoming 0? Speed looks fine. Spring is a big negative value. I guess that's just meant to be negative offset then. Jeez. Okay. That's kind of ridiculous. Make a Dead by Daylight clone. I don't understand why this is different. Why? How is this behaving differently? I have the same values. I'm doing the same calculation. This is the only real difference here. This is different. Do you see my castle? I did. Unless you just sent me something, then I did not see it. No, I saw it. I'm like way bouncier now. Am I not? Oh no, this can't be there. That's still not exactly correct. It's just, it's so messed up. Because if I walk into the edge like that, I will very slowly push up, is what should happen. Like here, I'm not pushing up at all. There's no push. Take a slight step forward, and suddenly there's a big push. Right? Demons are not hiding it anymore, I believe. Dude. Just warning, thanks, man. I love believing the world is gonna end. That's just such a healthy thing to think about. It doesn't literally drive people insane and just like to ruin their lives far worse than if the world was actually ending, because in almost all likelihood it's literally not ending. Literally not ending. Nothing bad is happening. Why is it weird scrolling? Okay. I doing that right? Wait, am I? I mean, I must be. Yes. Like, do I have to give it the velocity? Is that what I have to do? I have to say, hey, here's your velocity. Here's the velocity I calculated that you're moving at. I guess so. Because that just sucks. That just straight up sucks. That's just not working at all. I don't know why it doesn't work. I feel like it should work. But it's apparently just not working at all. So I give a step. I would give a I'll give it a speed. And then I just use speed. So up here, before I do that, this will move all the way down here. And then I have, where was this happening? Right above ground, I mean, obviously, right? It's right here. So then what I did was this would be ground normal dot the spring direction. I guess I can just multiply this by cosine theta then. Which I don't know, maybe I don't, maybe this is like the mistake. Maybe I don't do that. Oh, because yeah, I don't actually do that. I don't do that. I literally don't do that. Wait, so was that the wrong thing? Because I was doing it twice? Because then I can calculate speed. Okay, let me try that. I can calculate it way up here. That's where it was, I think. Okay, for some reason I bounced forever. Oh. Correct. Okay, that's still weird that this is happening. Okay, man. Okay. Speed. I'm so annoyed today. I'm annoyed by absolutely everything. If speed is 0, do that. Otherwise, I just accept it. I read. Alright, I get to take the dog out. I'll be back. I'm back. What can I do about this? You know what I think? I think maybe I just drop out the whole mass thing entirely. That might be helpful. Because when I use it, I do multiply by inverse mass, but it's kind of like, why? What's the point of that? Right? right? Total force times step. Because it is supposed to just be an acceleration. That means that this part makes it an acceleration. So then I could just take mass away. And I think I do understand why this happens with here. It's because of that. So it's because what I'm doing is I'm casting down, and I'm saying this slope is too steep to stand on, so let's cast down. Let's ignore it and cast down. And then I see the ground beneath me like normal. Right? But then there's a sudden jump where I'm not standing on this ground anymore. I'm actually standing like 20 centimeters higher. And I have no downward velocity, I guess. So that kind of needs to be continuous, really. I need to have a continuous change in my height as I approach it. So when I touch it, it's like nothing's there, and as that normal becomes more acceptable, I guess. I think essentially what I'm really looking for is to somehow make it that I mean, it's good for walls. It's not good for floors. Something that I could eventually jump up onto. Stairs as well. It's not good for that. So what I think I mean to do is, I guess, compute some sort of like average height between the two. I might even say Springcast can accept. Well, yeah, I think that's exactly what that is. So I can ignore speed now, I think. I really should not need that. I think speed's correct. Speed should be correct. Because I am still accounting for the spring direction. So I consider myself to be a low velocity, whatever, if I am or not. So essentially, if I have a contact point, and then I have my second contact point, I kind of want to like draw a line between those two points. And I guess that would be my first thought. And I mean, I suppose I could go like halfway between them, or I could use the cosine theta as my ratio between the two. So if this one is nearly vertical and this one's vertical, I don't know how that'd be possible, but just assume it is. I guess it's not. I guess it's always going to be something like this, right? So this point is vertical, this point is not, and essentially what happens is they start like this and then they become like this, right? They line up as you approach it. I want the point, I want it to be such that, I want it to be continuous so that as you approach it, your spring offset follows like some line between those two. So maybe it is just taking the height of that other one and saying, let's mix from our second length to our initial length using the cosine of both angles or something. Right, take both normals, cosine, or dot them together, and that gets you your mix. So when they're the same, I will use the height of the taller one, the first collision. When they are perfectly opposite, I'm using the first one. And I mean, that might be it. That might be it. And I can have a bias as well, which I guess this is actually my bias, isn't it? Or this is the value that I want to modulate between. So what I will do is I will do old normal, I guess hit position. And I guess I only care if it actually so I do that, and then I have desired height offset plus slope offset, I guess. So essentially this is going to say, because when I get in here, then I know, all right, I am telling, what is it? The spring that it's not colliding with the first one, but I don't want to lose that information. So at this point I say, has landed on ground for jump. True. Do this, I can say var old position vector 3 equals hit position. Okay, and then what I want to do is I want to interpolate between heights. Using normal alignment. So I just take the difference in these heights, and I want to interpolate between no difference and so the bias is in a sitting height. So I could say would be the equivalent. It'd be like I am subtracting from the length value. I mean, I guess that's just plus bias. I can just subtract. slope offset will be I take the vector between, well, this one's going to be lower, right? I expect this one to be a lower collision point. So I expect hit position here to have, well, I don't know, it's a bit weird. It's a bit weird. It needs to be in the spring direction. So I guess what I can say is I can do a spring. Spring, honestly, this should be like spring. So I'm gonna place it right there, right? So this should be the direction. So that's kind of annoying, writing it out like that. And this would be dot with the difference between so if first point's higher, second point's lower on this axis, on this direction. Also, I do kind of have a problem actually. If I make the spring not aligned to the Y, then this is going to be a problem. I mean, I guess I can just do spring direction dot with my transform, which should be, I mean, I guess I just look at my player. Player does basis times a direction. Okay, so that's how I do it. So I grab this, and we'll dot that with, and this is inverted, I believe, right? So I should go in the other direction. So this vector is pointing up, or I have the right vector to be dotting with. And so I want slope offset to be all right, let me do something here. Let me just print the offset, because I always forget what this looks like. Alright, so the value is very positive. When it's compressed, and it's very negative when it's not compressed. Okay. So what I can do is I can make it more compressed by adding to bias. So I can say the difference in height. Okay, this is what I'm looking for. This is the difference in height. So I think I want to say old position should have a higher Y value than that one. So I might want to say like 0.5 to 0, so we have a difference of 0.5. Okay. this will be the y component of that, or it should be, I believe. Or it is essentially just the height difference. The difference in the spring direction. So I'll just print a slope offset here. But I'm not going to add it yet. I'm not going to add it yet. Okay, I didn't realize the spider was launching off into the air before. I didn't realize that was happening. Okay, so I can't tell because I'm printing too many things. Stop doing that. Okay. Settle down. Alright, so 0.5. So what I want to do is I want to then dot these two collision vectors together. And as they get aligned, I use this value. Yeah, okay. 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 That's just straight up not even working. Oh, because I'm not adding it. Duh. So create a small change in the offset heights when I first touch it. Which I guess I can go slow speed so I can do it as slow as possible. Okay, so that instantly pushed me up quite. What is happening? It's just not working. Why am I moving? Why am I moving? Why am I moving? Like, what is this? I mean, I'm guessing it's because the spring doesn't extend down very far. Yeah. I mean, I don't know, maybe it needs to. Maybe it needs to extend further down. So that it can reach that. like down there, and then because I've grown the height from 1.34. It's 0.6. So I guess height offset here needs to be minus 0.6. So let's not do that. It shouldn't. It still shoots me up and then I fall down. Maybe it needs to be more than that. Does this need to be multiplied by... Does this really have to be multiplied by that? All those errors too. There's a lot of errors that printed. Yeah, what is that? Just insane. We can only assume it's because the force just becomes something ridiculous. Which is very upsetting that it behaves this way. Zero force. So it went from 9 to 284. So it just tried to accelerate me basically 284 meters per second in a single frame, right? Okay. That's also after multiplying it by the collision normal too. Which is crazy. How? How does it do that? Also, why is it 9.7? So weird. This also wasn't continuous either. Was it continuous? What is this other number I'm printing? So into 0.05, 0.07, 0.08, which is kind of a lot. honestly. It's kind of a lot. Maybe it should be 1 minus the sine or something. Like flip it around. Or maybe square it. I could square it. Maybe that helps make it a little more continuous. I mean, that doesn't do it. That just doesn't do it. It just doesn't do it. Wait, is that actually the damping value? In player? What? Oh, just... Wait, is that really? Yeah, it's that jump that's like really annoying. All right, let me try something here. Height offset. Let's do 0 and let's make it slightly longer. Yeah, and the -103. So this should be able to pull it down slightly. think it does also have the weird effect of this inverting itself. So what I'll do is I'll do this. Times the smaller value between That's crazy. Wait, that's actually crazy. No way. Stairs. I was gonna say, is this why I'm launching them? But no. It stops me from launching. I can't believe it. I actually can't believe that. This is crazy. I just stopped myself from launching. That I thought this would be like a... I'm allowing negative impulses now. And I made it go a little bit down. I could make it go down a bit further than that. I could make it like negative 0.8. Or... So I guess I could do... So this is minus 0.4 to reach that. So I could go minus 0.1. For a 10 centimeter grip or whatever. Maybe not so far. Maybe more like 7, 9. And then this used to be 0.13 or 0.03. I know when I subtract 0.1, so it's negative 0.07. It does have this thing happening though, which is maybe a bit annoying. I mean, that's just sliding. I guess I should test here because it's where it was really. Oh my gosh. I'm not flying. I'm not flying now. Do I fly over the edge when I go over this? A little bit, but you know, it's not that bad. Let me change. Let me make these steps be a bit. Like a 2-meter cube between them. Two, 5. These should be 8. Yep. Do I launch over the edge of this? No? It's pretty, I mean, a little bit, maybe. It doesn't turn red, at least. Okay, it does turn red, but... Is this correct? The absolute value between damp and spring, and then I just take the smaller one of those two, and then damp will be that sign. Well, I guess not actually, because this can still flip it. If they're both positive, or if spring is negative, yeah, I mean, okay, let me do a better trial here. If damp is smaller than spring, then if damp is smaller than spring and damp is negative, then damp will be negative 1.0 times the smaller value between right. Otherwise, damp is greater than spring. So then I can say if damp is negative, then damp will just be equal to spring. Damp is greater than spring, but it's also negative, so it'll just be equal to that. Otherwise, damp is positive and it's greater than spring. No, this is weird. I'm just setting it to spring. Damp is negative. Damp is positive. And it's greater than spring. Spring could be negative. So I think I actually just say, if damp is greater than spring, if spring is positive, we do this. Otherwise, no damp. So when damp is smaller than spring, we only care about doing something with it when they're negative. If they were both positive, so if damp is positive and it's less than spring, then spring is also positive. So damp can just be its value. If damp is less than 0, so it's negative and it's smaller than spring, which means we're adding to it, in fact. Let me say this. Let me say if spring is negative, is it really not just opening that up to be negative? Spring being negative means it wants to pull down, which means damp must be positive. Right, I only consider damp when damp is positive. I only consider damp when it's in the opposite sign of spring. No. I only consider damp when it's the same sign as spring. I think so. I don't know, it's a bit odd. Let me just do this. Let me get rid of force too. So I hit the ground as negative. These are opposite signs. So here, in this case, they're the same sign. All right, let me start in slow motion. And then I guess I'll print out my force, in fact. I would like to actually see the force so I can be sure it's not doing... This shouldn't be pulling me down, but... At least not at the start. So initially it's doing nothing and then it's pushing. And then I assume once I go under it will... Okay, sure. I did not mean to go in that mode. Well, I mean, it's good like this. Also, it's just so crazy that the spider is still just like flying off. Oh. Okay, apparently, alright, so apparently part of that was also actually changing this to be now walking over it. Because offset can be positive or negative when it's the other way around, when it's overextended. Okay, let me see this. Yes, that was a very different experience, climbing over that ledge. All right, I think I've got it. I think I've got it. So this is a little bit better, but it's still not quite right. I think what I'm really meant to do is just think about it correctly. And so spring could be negative and damping could be positive. That's what we want. Spring could be positive and damping. Wait, what did I say? Yeah, spring could be positive, damping can be positive, and that's a normal case. So spring is pushing me up, damping is trying to slow me down. Right? Then it can be that, I mean, what if I just don't do it at all? What if I just actually do both of the, what if I just allow it to be whatever it wants? Okay, so now I'm like very sticky to the ground, is what it looks like is happening. Okay. So it kind of is, it is pulling me down a bit. Alright, but maybe damping is too high for this now. I feel like 1.5. Right, like it's a bit too aggressive. Yeah, also it seems like I am getting some frames of it dragging me down. This is a weird thing that's happening. I don't know what that effect is. Okay. Well, I also did turn down the damping quite a lot, so maybe I just turn this back up. It's a bit I mean, shouldn't damping maybe it's yeah, because damping becomes a negative value, so I do end up with like a high. Let me see this. Yeah, so I did for a moment get this really high negative value. So perhaps what it really is that damping should be... Alright, let me just say this. I'll just do that. And see if that fixes the weird bouncing. A bit. It did help. Okay. I say a bit, it actually like fixed it. So I guess I can just say if the signs disagree with each other. Otherwise, um, damp will be equal to the smaller value between damp and spring. And when I say smaller value, I guess what I really mean to say is in this case. So if they're both negative, then I make it the smaller power of those two. Am I jittering a bunch? Okay, now I've done something strange. Okay, just make it... If spring is positive, then I can say if damping is positive, then I would like the smaller value or the larger value. Damp and spring. Otherwise, I want the smaller value. Why is it jittering worse and worse? What's happening? Okay, man. This is so strange. Spring is just a larger value now. Like, why? I haven't done anything. Spring is just this large value. Wait, and I print these and I put the force. How is the force 0 after this? Okay, I feel like just something wrong happened there. I don't really know. What is going on? Yeah, what? Why is it 0 when it's like that? It's 45 minus 14. Wait. Oh, no, no, no. If damp is negative, it's still weirdly bouncy. I don't know why. Oh, is this because I still have a... 0.7. I don't understand. All right. If spring is negative, damp is 0. Otherwise, spring is negative. Damp could be anything. Well, spring is positive and damp is negative. So I guess I'll just leave it. The spring is negative and the damp is positive. A bit better. It's these things that happen. This flashes. I get a 10 and a negative 13, so I push up. I mean, I guess what I really mean is just that damp can't flip the sign of spring. So if they disagree, that's like a positive minus a negative, which is just adding. If it's negative minus a positive, then that's just adding. So I don't really care. If the signs do agree, and damp is negative, if the signs agree and the damp is negative, then damp should be, if the signs agree, damp is negative, means they're both negative. Well, I guess I should say if this is greater than or equal to 0, this means they're positive. I want the smaller value. Otherwise, I want the larger value. I think that's what I'm looking for. Yeah, it just doesn't stabilize. It never stabilizes. I get a 3 followed by like a 10 and then a negative 3. Also, I don't get it. Why is it... Does this not have... No, the margin is 0. I don't know, should this be positive? Like 0.1 or something? And now it's like gonna be consistent somehow? Very stable. It's the fact that it's 9.75. Why is it that? Why is that keeping me stable? I don't know. Okay, so I instantly made that jump happen, which I'm trying to stop from happening. Yeah, which is here. They disagreed. Right, okay. If damp is positive. Yeah, because what happened here is they added together too strongly. Like, why did that happen? Why did they add together so strongly? Should speed just be... Should this just be an absolute value? So it's always positive? And then damp is just the smaller value between these two? No matter what? I'm assuming if I walk into this, it's gonna like shoot me to the ground or something. Okay, it's behaving strangely. Why? Why am I still working on this? Or so this happened. I get a huge... The spring went up like to 30 or whatever, but then the damping said, oh yeah, we're doing negative 20... Negative 280. So like this huge, like, I have an instantaneous impulse, essentially, of 232 meters per second up. Right, so that happens. That is incorrect. That shouldn't be happening. So why does that happen? Well, it's because speed becomes a huge value, right? That's not really accurate. The spring's actual velocity is not this value. It's how far, how much I'm actually moving. So, okay. All right. I'm actually gonna work on this off stream for a while, because this is getting ridiculous. I need to really, I think probably just like focus up and figure it out. But that's gonna be it for today. Thanks for watching. I'll be back tomorrow. Goodbye.